So.
And thank you for having me here today.
Yeah, it's really great. We had a great day, a lot of interesting topics and a lot of information for all of us. And it's really great talking shop with all those great people coming here, taking the time, presenting stuff they really like and they're really passionate about. So it's really cool.
Yes, it's cool.
Yeah.
There will be recordings later available on YouTube, I suppose.
There will be, yeah, and it will take a few weeks to process the video, but they will be available to on the YouTube GroupBy channel. So
Yes,
all of the recordings will be available.
Like last time.
Correct, yeah. So it's not my area of expertise, but it seems it takes a lot of time cutting the video material and post-processing and encoding it. So it will take a few weeks to prepare the video materials and load it up.
There is some job, yes, of course. But this is, I like more this approach than that you actually record live, because on last GroupBy I was presenting, we had 2 pre-record sessions.
Okay.
And usually you take free time more than to prepare it and publish it than actually just have a session.
Yeah, and you get the feedback of the attendees, so I like that a lot. Yeah.
And also, but it's not a problem if you, for example, leave the recorded session, then actually you can be on the question and answer all the time, and this is also okay.
Yeah.
But so both approaches has something,
pros and cons. So if you like, we're at the hour. The stage is yours. So
yes, thank you very much. So my screen is visible. Okay. So welcome to the last session of the day, I suppose. And I'm happy to speak on this great event. So of course, don't forget to look at the code of conduct that you can see here on the screen. I can give you 30 seconds if you want to read it. Of course, I'm sure that everybody will read it. Otherwise, you can go to GroupBy code of conduct, and there is on the website this material. So, okay, I hope I can continue. So, who am I? I am a developer from Croatia. And for many years, I was a developer using ASP.NET with C#, and also in my more than 15 years of my professional experience, I was using many other technologies, for example, ASP, the vanilla one, WinForms, Clarion, Oracle, also Oracle Forms, etc. I started using SQL Server from version 2000, and recently I oriented myself in SQL Server development and optimization. Last 9 years, I'm working for a great company named Span, and my current position is senior database developer. For more than 2 years, I'm leading the Croatian SQL Server user group, and in 2019, with some friends, we organized the first SQL Saturday in Croatia, and currently we are organizing the 3rd event for this year. I'm also one of the co-founders of Data Weekender conference, and I am writing my blog about SQL Server. Last year, Microsoft rewarded me with the MVP status for my contribution in the community. I'm also Microsoft certified trainer, and I speak on various conferences and events. Thank you to the sponsors, because it's really hard to organize a good conference without sponsors. I know this because I'm organizing a lot of stuff, and it's easier when you have some financial background and help. So let's go to my session finally. The session name is SQL Server New Functions, Syntaxes, Tips and Tricks, as you probably know, because I suppose you are on this session because that if you did read the what I will talk about. So this session will be somehow retrospective of some new features introduced from SQL Server 2016 up to date. Most improvements since SQL Server 2016 up to date for development purpose has been introduced in functions related to string manipulation. In addition, there are some news related to other segments. And of course, I must tell you that this session is related only to new functions and features and not strictly about performance tuning enhancements. So I hope that you will enjoy it. So let's go. SQL Server 2016 introduced us few new things. So first is string split, and this is a table value function introduced, and for splitting string values by a separator. It has, of course, multiple usages. For example, you can use it, for example, like an input parameter for a stop procedure or whatever you like. The function returns a single column table with parts or fragments. The name of the column is value. Return type depends on any of the input arguments. So nvarchar, nchar will return nvarchar, and all others will return varchar. The table value function can be used not only in the select statement to get the results in column, but also in the where, or for example, in the from statement, like for example, in the join or cross apply. From my experience, I know that there are many theories, approaches, and solutions to split strings in SQL Server before the existence of string split functions. The one that I prefer is using XML. And if you want to read more about different methods and benchmarks, of course, for splitting strings, you can take a look at a good article by Aaron Bertrand. And it was on SQL Server performance.com, but actually there is a new URL. I don't know it right now. Second function is string escape, and it escapes special characters by a escaping rule. And you can use any rule you want while the rule is JSON, of course. It's something like Ford. You can get a automobile in any color you want when the color is black. So the point of this string escape is actually that SQL Server 2016 introduced JSON support, and it was logical to introduce the string escape because you must actually escape special characters to be able to convert the document in JSON format. Format message, it's actually an old statement introduced in 2008 SQL, and it is enhanced in 2016 to accept a message string argument. And this means that you can use your own string to build a message. If you are also a developer like me, maybe you are dreaming about be able to format and concatenate strings in SQL Server, something similar to, for example, C# string format or something like that. Okay, let's jump on the first demo. So this statement is full of demos. So string split, okay, I have here ingredients for a mojito cocktail and separated but by comma. And I'm using the new string split to get all the ingredients. Let's see what will happen in the second example. Notice, for example, that here I have two separators and I don't have a string between them. And the result is an empty string. So if in some cases, maybe you would like to remove this result. Also, one downgrade of this function, from my point of view, is that you can use only one character for splitting, and it's impossible to use more than one character. So if you would like to use string split to split a string by more than one character, you must actually first use the replace or maybe write another function or something. Okay. Let's see some example from the real database. So we have warehouse stock items. Actually, this is an originally a JSON document. Is the column text is JSON. So I was first using the replace JSON characters special for arrays and then I'm using the string split to get the stock item name for this table. Also, this example here is, for example, if you would use, for example, the split string for input in the store procedure or something. So I'm getting some list of stock items IDs, and I want to get all the invoice lines that exist in this input parameter. Okay, this is a very well-known function for splitting string using XML, and this is the old approach before the existence of the new function. As you can see here, the work is done, of course. But what I want to achieve here is I want to compare these two approaches to get some performance insight, how it is working, the new function. I will run the same query, but in the first example, I will use the function, the XML function, and in the second example, I will use the new split string. So let's run it. Okay, the result is here. Pretty much, let's take a look at the execution plan. So the first query was using 64%, and the second query with string split only 36%. And if we look at the messages, we will see that the first query with XML was using the temp object, and it has 2 to 7 logical reads more than the second one with string split. And also, if you compare the times, you will see that the first function with XML was using 31 milliseconds of CPU time, and the second only 16. So I would like to tell you that this approach is better. So the string split actually is not so bad. Okay, string escape, of course, as I told you, it's for escaping special characters, but only you can use the JSON. So these are some examples of URL and new lines and tabs, characters, whatever. So this is escape for the purpose of using in JSON document. This is a special character actually that is escaped like under /u and the number of this character, and the null is escaped like null. Format message. So what I want actually, I want to concatenate person name with drink name. So Damir likes gin tonic, and this is the old approach. For example, And if we extend this example a little more, so for example, I want to add a number of drinks, for example, then I have the person name plus will order, and then I must use the cast, of course, the number of drinks, and then blah, blah, blah. I will get the result, of course, that I was willing to get. And also this approach is not so good, because if we usually have null values, like in this example, the whole result will be null, because null plus something is always null. And the bulletproof solution would be something like this. So you have is null. So I would use this is null for every parameter, and then I will get the result. But now with the new format message parameter, I can barely write this. So I have one variable, second variable, third variable. I have here the that what string I want to concatenate and what it will be the result. And I can use the placeholders like string for the first variable, string for the second variable, and string for the third variable. And of course, after the first parameter, I can pass all the variables. And when I run it, I will get this nice result. And this is more intuitive, of course, than this one here. The only problem, of course, is that the casting is still required. So if I didn't use the cast, then I will get an error, of course. And let's see what will happen if we, for example, have a null value like before. So null will be replaced by null in the here, like seen here. And of course, this is something that you want to generate for your production database, drop statements for every table in your database, and don't do it on production, of course. But it's a really fast way to get this. Okay, let's return to our slides. Do we maybe have some question, because I see something? Okay. Thank you, Thomas. Actually, there is, I see that Thomas find the link from Aaron Bertrand. Thank you very much.
You're welcome.
Okay, SQL Server 2019, 17, sorry. I'm already going to the end of this session. Introduced some good new functions. So first is stream. Of course, it is a new function introduced, and it removes special characters from the both sides of the string. So at the beginning, at the end. Of course, before the introduction of stream, you could use the old very known system L-trim, and then after that R-trim for the left and right part of the string. And this is actually easier to use only one function if you really need it. And you could also write TRL function for that in C#, but I suppose that this was not the quickest way to accomplish this task. String aggregate function, it is of course for string aggregation, and it's pretty much the opposite from string split, like shown before. And also there are many theories and approaches and solutions to aggregate data in SQL Server before the existence of string aggregate function. The one that I actually prefer, I was preferring, is by using XML with stuff, but maybe this is not the optimal one, and later in the demo we will see how they are performed. There are also cool articles on the internet for how to aggregate strings in SQL Server, but let's stick to this for now. Translate. So maybe you are thinking that translate has something in common with language translation. but then you are completely wrong. But I suppose that it would be cool actually that you can translate in SQL Server. But the function translate replaces multiple characters inside the given string value. The function translate cannot be used to replace a character with an empty string. And this is only possible by using the alt function replace. Concat VS. SQL Server function concat is introduced from SQL Server, let me remember, 2012, I think. And simple as that, it returns a string that is the result of concatenating two or more string values. The new function concat VS is introduced in SQL Server 2017, and it concatenates a variable number of arguments with a delimiter specified in the first argument. So basically, if you need the same separator between two or more strings, then concat VS is the command you are looking for. Okay, new demo. Trim, of course, this is simple and very fast, so it really does not need much to explain. So we have some spaces before and the end of the string, and the old approach was, of course, to use the L trim and R trim in combination, and now you can use only the trim stuff. String aggregate. So, for example, I want to aggregate gin and tonic by using space, and of course, this is the result of this. Okay, let's use string aggregate for to aggregate all the customer name from sales customer. And as you can see here, I get an exception because it says the result exceeded the limit of 8,000 bytes. And why it happened? It happened because the customer name, as you can see here, is an n-varchar of 100. So when string aggregate take strings, they want to aggregate them, he suppose actually that the result will be not more than 8,000 bytes. Because the input was only a varchar of 100 length. So if you want actually to achieve that, first you must cast actually to the input value to the n-varchar max. And now if we run this, we will get actually a pretty big string, and these are all the customer names aggregated. So of course you must know your data and what you are aggregating to get the exact result. Okay, what will happen if you want to aggregate something with null? So null value will be totally ignored, of course, and this for me is okay. And if you actually want this null somehow, then you can always use the is null and to replace with something. Okay, we can of course use string aggregate to aggregate all the invoice IDs for customer. But why I'm showing you this, the point of this is actually that if you want to be sure that actually this result here is sorted by something, for example, order by invoice ID, then this is the correct syntax to be used. So you must use string aggregate within group and then order by invoice ID. Now, when I will run this query, I am sure for almost 100% that these numbers will be sorted by invoice ID. Okay, let's see the performance, of course, like before. So this is the old approach with XML and stuff for aggregating sales customers invoices. And this is the second with string aggregates. Let's run it. What will tell the execution plan? The execution plan tells, oh, the first one with XML take 100%. Okay, of course, this is not really totally true, but the point is that actually the first one has taken up to 125 milliseconds, and the second one was using only 47 milliseconds to complete. So the of CPU time. So the second one is much faster with string aggregate. Translate, okay. So it's not for translation, but you can use it for something like this. I have a string and I want to replace the good smileys with bad smileys. So with sad smileys, sorry. So this is actually what you can do with this function. Of course, the replacing with an empty string is not supported. So you must always have something for the replacement. Okay, for this you can use the old function replace, of course. But the cool thing with translate actually that you can specify more than one character to be replaced. So in this string value, this bracket will be replaced by this bracket or this character, and this character will be replaced by this character. And if you would like to achieve this result by alt replace, you must call this replace twice, of course. And if you want to replace, I don't know, all the numbers, for example, then you must specify 10 times the replace statement for every number, for example. So actually in the translate, you can use more characters. One, and this is the last example. So nothing really great, but it's cool to know actually that you can use it for something. Okay, concat and concat vs. So as you probably know, this is the old concat. So it requires minimum of 2 parameters. And for example, I will concat this person name, drink name, and number of drink. And take a look actually that no casting was required to get the number to string. So actually concat is pretty cool because it doesn't require casting. What will happen with null? Nulls are actually ignored. And actually this is also sometimes cool for the need of that. And also you can generate drop tables for every table in your database with concat. And what's the difference actually with concat vs? So concat vs is the new function, as told before, and it requires minimum of 3 parameters. So the first parameter is a delimiter, and after that you can specify 2 or more columns that you want to combine by using the same this. Okay, so this is, for example, the example of using concat to generate, for example, a comma separated file. And the only downgrade of this approach, for example, would be if you have null values, then your comma separated file, CSV file, would be not correct actually, because like said before, null is totally ignored. And if you want to include this null stuff, then you must use the isNull function. And now this CSV would be a great one. Okay. Are there maybe new questions or something?
Just one regarding the slides, where we can find them after your session.
Oh, we will manage something.
Okay.
Or maybe I could send you. You will maybe publish this somewhere or not.
Yeah, we can do that.
Okay, great. So you will find slides somewhere. Sorry. Okay, SQL Server 2019. You know, for this great error, string or binary data would be truncated. A very frustrating one. And because it's almost impossible actually to detect what insert, what statement, or for example, what record is the cause of this issue. So imagine actually that you are trying to insert some values from another table, or for example, a really complex select statement. And you actually would get this error, string or binary data would be truncated, and you don't know what caused this error. But the Microsoft team did a really great job in SQL Server 2019 of the product, because now you have some basic parameters of the error itself. First of all, you know the database, the table, and also the destination column of the error itself. And also you get the part of the value that caused the error. So it's much easier to actually understand where the error occurred. But of course, there is a small problem. So keep in mind that the error number of the message changed actually from 1152 to 2628. And for example, if you are using in your code and you are referring to the old error number, you could actually turn this feature off on the database level. So by using this alter database scope configuration, set blah, 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 you could turn off this feature in SQL Server 2019, and you will get the old error message in this case. Secondly, SQL Server 2019. So actually before SQL Server 2019, storing some characters, for example, ASCII, in SQL Server was somehow limited. So SQL Server supports Unicode characters in the form of nchar, nvarchar, and ntext data types that are actually using the UTF-16 encoding. The penalty of this was that you need to pay the price for more storage and memory because you had to store all the data in the Unicode UTF-16, even, for example, when you need only ASCII characters. UTF-8 is actually the dominant character encoding system for the World Wide Web, and it is used in over 90% of all web pages. UTF-8 database support allows application internalization without converting all the strings to Unicode. And UTF-8 support in SQL Server 2019 is implemented as new collations. And in total, there are 1,553 new collations and that you can choose for your database. And you can identify them because they finish with the UTF-8 suffix, like seen on this image here. So if Google Translate doesn't lie to us, we are trying to translate SQL Server 2019 support UTF8 collation to Russian, of course. And notice, for example, that the result for the query where we are using the varchar data type is incorrect because we lose the Cyrillic characters. The characters are displayed only if you are using the nvarchar data type. And the second database, on the right side of the screen, the UTF8 database, the result is now correct, meaning we see also the Cyrillic characters in both data types, so varchar and nvarchar. And notice on the right part of the screen, you can see this column data length. So meaning that there is a slightly improvement in the consumption of the space needed for storing Cyrillic characters using UTF8 encoding. And for example, if you have really large text, so this slightly improvement can actually be a bigger improvement. Demo. Okay, let's downgrade our database. Let's drop a table and create it and try to insert something. So this is a really small and easy example to understand. But imagine, for example, that this insert is based on some so big select statement with many columns and based on a really large table. So actually you wouldn't know what was the column or value that actually give us this error here. So now let's actually upgrade our database to 2019 and let's try actually to insert again these values. And now notice this. So string or binary data will be truncated in database name, table name, column, last name, and the first part of the truncated value is starting with Daniel. So now I can actually see that this is the last name, is the column. Daniels seems like there is a problem with this. And what's the problem? Daniels is more than 6 characters that actually I was trying to insert in this example here. So it's much easier actually to understand where the error occurred. Okay, UTF8, sorry. I'm gonna drink a little bit of water. So these are actually the new 1,500 collations that actually are ending on UTF8. And these are all the collations you can use for the UTF8 support. I will create actually some test databases. The first one will be UTF8. So the database UTF8, collate Latin 1 general UTF8, and the second one is named non-UTF8. So I'm using the standard collation. And I am trying to actually select this in string Russian in these databases. So let's do it. So first one is the non-UTF8 and the second 2 strings are from the UTF8. Notice here that the varchar, so this is the varchar result. We have some, we don't know what is this, so it's impossible to read it. Okay, the size is really small, but the result is not actually good because this is not what we want actually to store. The second one is okay, but the data length is actually larger. It has 78 length, but because we are using the nvarchar. And in the second database, the UTF8 database, I am getting the same result. So the correct one in both data types. So the varchar and the nvarchar are correct in this case. And notice here that actually we have a small benefit, so we are using less space than when using nvarchar. So this is actually what we want to get here. Okay, let's return to the demos. I see the chat. I don't want to be truncated. Okay, for you, we will change the column. Okay, no questions, seems like. So, compress, sorry?
Not in the Slack channel either, so you're good.
Oh, yes, I'm not looking Slack, so. Okay, compress and decompress. SQL Server compress and decompress are introduced in SQL Server 2016. As you probably know, SQL Server already supports row and page compression of the data. And the really compress function is not the replacement for them. The function returns the data type of var binary max that represents the compressed content of the input. The function uses a gzip algorithm for data compression. Compressed data cannot be indexed, so take care about that. It is actually recommended to use this function only on rarely used data, maybe some log data or, for example, XML data then that you are not using all the time, because the data is not simple readable or usable if first not decompressed. And the compression, of course, takes CPU and time. On short text values, the compressed data could use more space than the original data. And this is, of course, normal behavior. Like, for example, if you're trying to compress data file with, I don't know, one string inside, and of course, the zipped file will be larger than the original one, because you must have some metadata, whatever. Decompress should be actually the exact opposite of the compress mechanism. We agree on that, yes, but it's not really the case, because the function returns the data type of var binary max. And actually, there are two possibilities. Or the first one is you are able to read var binary. Or the second one, if you want to get the original value, you must cast the result in the original data type. And this is funny. I will show you some examples of that. So you must know what was the original data type. Okay, demo about compressed and decompressed. Okay, this is, let's say, a large string and varchar max. And this is, of course, the compressed string. It's nice, it's not readable, but it's compressed. So let's see how much is compressed. The original size was 1152. The compressed one is only 400 and something. And we have a compression rate of 62%. But if I try to compress a really small string, I will get minus 20% compression rate, meaning that the compression size is larger than the original size. Okay. I created before some test table. So I have sales order lines and compressed whatever. I inserted rows. And here you can see a sample of this data. So the first one is a description. It's not compressed. And the second one is the description compressed, of course. And I want to show you the difference between the data compression none, the row one, the page, and finally the compressed one. Let's run this. Wait a little bit. So the original data size was 43 megabytes, somewhere around. The page and row compression was pretty much almost the same. So you have 22 megabytes of storage used. And the third one with compressed function is 32 megabytes. So somewhere in between the row and the page compression. But of course, sometime it's really good to use this compressed stuff. This is the second example where actually I was compressing XML, and notice this is the original one and not compressed, and this is the compressed, this XML. And if we really we make the comparison of this one, we will see that actually the compressed one is almost the half of the size. So it's a pretty good compression for XML data type, but of course we are using some more CPU for that. Okay, let's have some fun with the compress actually. So I have Damir like gin tonic. I want to compress and then decompress this. Let's do it. And of course, I don't know to read this, and this is not correct, of course, because the result of the compress is var binary max. So it's the casting is required for this. So let's compress, decompress, and cast to the original data type. When I run this, now I have the decompressed value, and this is readable, and this is okay, of course. But let's run this, the first example here. So I was starting from compressing Damir like gin and tonic. I decompressed it, and I get only D or something. And this is not what I was aiming for. And the reason for that is that actually I started with nvarchar max, and I was trying to finish with varchar max. And if I don't understand my data model, I can get these completely wrong examples. The second example is even more funnier. So I started with varchar max, and I finished with nvarchar max. And I'm really not sure if this is Chinese or something. And actually, the result is not so well. So, like always, know very well your data, and you must know what you are doing. Okay. Let's see some example here. So, what is this? The first one is the order line XML that's not compressed. The second one is actually the same table. Actually, I'm lying to you. It's the second table, and it's the table with compressed data inside. And so to be able to get the original value, I must, of course, decompress it and cast it to XML. Let's turn on statistics, and let's select this, and let's wait a little bit. So the first 10,000 rows, because I don't want you to wait the whole day for my CPU to finish. And let's first jump to the execution plan. So the non-compressed one says, oh, I take 66%. The compressed one take 34% of the query. But something is really wrong here. Let's run it again. So see this. The first one is momentarily. The second one is not so momentarily. Now, let's take a look at the messages and try see what happened actually. So the first query without decompression take 94 milliseconds. The second one with decompression take 1 second of CPU time. So this is more than 10 times more. But SQL Server is basing this execution plan on logical reads. So actually, the first query had almost 20,000 logical reads, and the second one had only 10,000 logical reads, 9,900, whatever. So actually, the SQL Server thinks that the second one is better and well performing, but it's really not the case because we take 10 times more for the same query. So it is good to use this compressed if you are using it on rarely used data. But you must really have a strong CPU for that. Okay. So we are finished with compressed and decompressed. Let's return to the slide. And what time it is? Okay, I have like half hour more. So this is cool. So we will pass some things a little faster. So for example, create or alter is a new SQL Server syntax extension introduced in SQL Server 2016. So after many years, SQL Server introduced the possibility to create or alter an object depending if the object already exists or not. So currently, supported objects are create or alter are store procedures, functions, triggers, and views. So you can see on this example here, so create procedure, some procedure, new function, blah, blah, blah. And if this function already exists, I will get an error, of course. But the second way to do this is if object exists, then drop it and then create it, or maybe alter it or whatever. And this is a lot of text to write, of course. So you could actually use the create or alter procedure. And when running this, you can run it many times as you want, and you will not get an error. Drop if exists, a.k.a. is a new SQL Server also syntax extension introduced in SQL Server 2016. And of course, you can remember a lot of situations when you need to drop an object. And for example, when using temp tables or store procedures or maybe some TempDB stuff or whatever, and you want to drop something, but this object does actually not exist. So you will get an error message, and this is sometimes frustrating. And now you have the drop if exist statement, which is basically a conditional drop statement. So still as before, you can run it only if you have adequate permissions. And if the object exists and you don't have adequate permissions, you will get no error message. The reasons for that is that the drop if exist simply suppress the error message. And currently supported objects are procedures, tables, assemblies, roles, triggers, views, role, blah, 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 blah. The list is pretty much big. But of course, I have a candy demo after that actually, thanks to somebody, you will see, and it's funny. So wait a little bit. Date diff big. In short, it is introduced in SQL Server 2016. Date diff big is almost the same function as date diff, with the only difference about the big part of the name. So date diff is introduced in SQL Server 2008, and it's commonly used already. And it's actually for a time span between two dates, of course. The difference between the old date diff and date diff big is that the function return a big int value. So the date diff was using the int, and this is returning the big int, representing the count of the specified date part units cross between the specified start and end date. So now you can actually handle much bigger values, and also you can get the overflow message, but it is hard to get it since you are now using the big int data type. It can be used, of course, in the select statement, but also in the where, having, group by, and order by clause. And the last feature I want to show you is the hash bytes. So in short words, hashing is a process of generating a value or values from a string of a text by using a mathematical function. SQL Server hash bytes was introduced in SQL Server 2005, and it was supporting only the MD2, MD4, MD5, and you can see on the screen these hash algorithms. From SQL Server 2012, there is additionally introduced the SHA2 256 and 512. And prior to SQL Server 2016, the input value for hashing was limited to 8,000 bytes. So starting from SQL Server 2016, the limit does not exist anymore, and you can use it for n varchar, var binary max, and input data types. Starting from SQL Server 2016, all algorithms except the two last are deprecated, so they actually will continue to work, but only the last two are recommended for usage. Okay, let's jump into demo. So, create procedure. Once, okay. Secondly, oh, I get an error. Okay, now this is the bulletproof solution. First I'm checking, then I'm dropping it, and then I'm creating it. I can run it how much time I want, but it is a really large script for that. But now I can use the create all alter, and I can run this as many times I want, because it will be created or altered based on if it exists or not. Secondly, drop if exists, so it is a conditional drop statement. So let's start to drop a function that doesn't exist, and it's not possible. I get an error message every time. So actually, I could also check and then drop it if exists, and I will not get an error. But now I will use the drop if exists, and I can run it how much I want, and it's cool because it is not dropping. But now, thanks to Erland Sommerskog. Erland Sommerskog was watching my similar session to this once, and he had some concerns. And really, Erland is a great guy, and he knows SQL very much, of course. Take a look on his blog if you like. and maybe listen some his sentence when you have the chance, because he is really a great guy. So let's create two tables. Now I have the secret table and the official table. I am creating some plain user, okay, without login, and I will grant the select on the official table. So this user has only the select right to the official table. I will now try to execute this part of the code like this plain user. And let's try to drop the three tables. So the secret table, the official table that actually I can read with this user, and no such table is a third non-existing table. When I run this, I will get, of course, 3 errors. And really, it doesn't exist or you don't have permission. And this is okay. So we were aiming for this, of course. So this is the old approach. But now we will try to run the same 3 queries and try to drop the 3 tables with if exists statement. And take a look. Oops. What happened actually? Cannot drop the official table because it doesn't exist or you have permission. So actually, drop if exists didn't suppress the error message. We still have the error message, but what happened? The secret table is actually the table that my user has not adequate permission, and actually it's dropped or maybe not, we are not sure, but we didn't get the error. But the official table, actually we get the error message, and really I was not hoping for that. So then it's not working every time. It depends about your rights, of course. And no such table is, of course, maybe dropped, maybe not, but the error message is suppressed. Okay, let's return here. And now I'm myself, the STA, super admin. And now I was able to drop all the 3 tables, maybe yes, maybe not, but there are no error messages. So thank you, Erland, and have fun with this. So let's jump on the date diff. So I want to get the date diff in week numbers, days, hours, minutes, seconds, and milliseconds for 1 day. So 24 hours, of course. When I run this query, the result is okay, of course. But what will happen if I try to get microseconds? So it's only 24 hours. I will get, of course, an error because 1 day in microseconds has more than int. So there is an overflow. Now let's try actually to get the same result with date diff big. So I will, let's go for microseconds, but only to nanoseconds now. And when I run this script, I will get the result. So really, if you really need a large number of time spans between 2 values, go for date diff big, if you really need it. And the last one is hash byte example, I think. So let's see what is this. So this is my test data, and this is the hashed value by using this hashing algorithm, and this is okay. So here, for example, we can make a comparison between all the hashing algorithms we have. So MD2, 4, 5, S, okay. Notice here that the only difference is actually in the data length and also somehow in the security, because it's harder to get this cache than this, for example, and also you are using more CPU. But SQL Server caching it's not using the salt. So what is the salt? actually. Result is a mechanism. If, for example, you want to get a different hash for the same input. And when you are running the hashing twice in SQL Server for the same string, you will get totally the same result. So these hashed values are the same. So sometimes this is not good, sometimes it's good, of course, because later on, if we will have time, in the short JSON example, I will show you a really cool way of using this hashing. And actually, it's good that actually there is no salt mechanism. But if we run the same for different data types, the result will be different. So only if you are hashing the same data type, you will get, of course, the same result. But if different data types, you will get distinct results. And okay, here you can get some. For example, this is one example of hashed invoices. So actually, I am hashing, converting actually all columns from one invoice to XML, and then I am hashing this. And this is actually the hashed value for this. And if you are maybe asking for what we need that, we can actually use this to compare two tables if the records has been paid, for example. So if you have two systems and you want to see what records have been changed to update from one system to another, you can actually use the hash with converting first to XML or even JSON. And it's really cool because now you must only compare one value, the hashed value, between two records and not all the columns. So you have the problem with comparing all the columns sometimes because you must, for example, take care about nulls and whatever. So many problems you have. And this is a simpler result that I want to show you just to understand what happened. So these are some test records. And if you notice the hash values, you will see from the airplane that these two records are the same and these two records are the same, of course. And if we compare these tables, so we pretty much are the same. So it's pretty cool and easy to actually confront two records by using hash value. Okay. Are there maybe some questions, or I can jump to the slides?
No questions at the moment.
Great. So, greatest and least. So currently these functions are supported only on Azure SQL, but we hope that in the future it will be also available on-premise version of SQL Server. But when and how, we are not sure still. So the both functions actually take a list of expressions, and this is actually a list of comma-separated expressions of any comparable data type. The function requires at least one argument and supports no more than 504 arguments. Each expression can be a constant, variable, column name, or function, and any combination of arithmetic, bitwise, string operators, aggregate functions, color subqueries are permitted. Return types. The return data type with the highest precedence from the set of types passed to the function. And if all arguments have the same data type and the type is supported for comparison, the function will return that type. Otherwise, the function will implicitly convert all the arguments to the data type of the higher precedence before comparison and use of this type as the return type. For numeric types, the scale of the return type will be the same as the highest precedence argument, or the largest scale if more than one argument is of the highest precedence data type. So take a deep breath and read this on MSDN. The demo will be better of this, but I will just tell you a few remarks and limitations of these functions. So all expression in the list of arguments must be of the data type that is comparable and that can be implicitly converted to the data type of the argument with the highest precedence. Implicit conversion of all arguments to the highest precedence data type take place before the comparison. And if implicit type conversion between the arguments is not supported, the function will fail and you will get an error. If one or more arguments are not null, then the null arguments are ignored during comparison. And if all arguments are null, then the greatest or least will return null. Okay. The following types are not supported for comparison. So the varchar, var binary max, and varchar max exceeding 8,000 bytes, cursor, geometry, geography, image, blah, 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 blah. The varchar max, var binary max, and the varchar max data types are supported for arguments that are 8,000 bytes or below, and will be implicitly converted to varchar n, var binary n, etc. So of course, if you are asking what are these functions, maybe you know them from other database systems. So the greatest returns the maximum value from a list of one or more expression, and of course the least, this function returns the minimum value from a list of one or more expressions. Okay, there is much talking, but the demo is sweeter. So, greatest. So these are the two examples. Of course, I have three numbers here. I want to find the greatest value. I get this is the greatest value. And of course, this is the second example when using it with string values, of course. And this is the example is actually the greatest string because of the sorting from Z to A, whatever. I will use a test table. And I will insert some 1,000 and something test rows. So this is one usage example of the greatest. So for example, find me for every, I don't know, invoice or something, the greatest value between the three columns in this table. So this is actually the result, as you can see. And otherwise, if you are not using greatest, maybe you could use something like case, switch case, or whatever. And sometimes this greatest is really okay. But you can use it only in Azure for now. Okay, let's see comparable data type. So actually, as you can see, I have two strings and the third one is a number. But it's all good because the implicit conversion was possible, of course. And in the second example here, I get twice the error for every statement one, because SQL Server was unable actually in the first example to cast this expression to data type int, because he was not sure actually that this is decimal and int has a higher precedence of a decimal. And the second one was a problem because the string has a lower precedence of int also, so we get this error. And third, this example will show you what will happen if we try to use it with null. So in the first example, you get the value because not all the parameters are null. And in this case, the null is ignored. But in the second example, the result is null because, of course, if we try to compare what's the greatest value between three nulls, you will get a null because it is impossible to calculate it. But it's cool actually that if you have one or more values, then you will get the result like here. Okay, this example will show you the error because we have more than 8,000 bytes, sorry. And also here with XML data type is not supported for that. So actually these are small limitation of this function. So it's possible only to compare smaller than 8,000 bytes. I want to show you a few more slides and two cool demos. So I think that we can skip actually the list because it completely the opposite like the greatest. But only, of course, you will get in the first example the lowest number, and here you will get the first, and completely is the example is the same. For example, here you will get okay, sorry. In this example, you will get the smaller number between these three columns, and it's completely the same thing. Okay, let's jump still on the demo view, on the slide, sorry.
So for your information, we have around 15 minutes left until the last starts.
Huh? I know. So I decided to not show the list because it's completely opposite of the greatest function, but I want just to have few slides about JSON really fast and one small demo why actually I like JSON. You can actually find on GroupBy YouTube channel the whole session of more than 1 hour just about JSON. So I will actually not stick much in details, but only I want to mention some little things because like other things explained in this session are introduced from SQL Server 2016 up to date. And JSON is one of the features that actually was introduced in SQL Server 2016. And maybe you have a question why. So why would we support and use JSON in SQL Server? So the answer to this question is that like XML, JSON is a standard and it should be supported. Other vendors support it, for example, Oracle, PostgreSQL, and many others. And some of them, such as PostgreSQL, are very serious and robust, of course. And many different frameworks in these days use JSON natively, web services, web applications, and whatever. So this is the reason why JSON is important in the way of SQL. So I will actually not show you all the demos now, and I will also skip some slides, but I will just in short words tell you that JSON documents is created similar to XML, but for XML you are using the for XML, and for JSON you are using for JSON. And you have two modes supported, and you have some additional options that I will not consider right now. But please go to GroupBy YouTube channel, and there you can find the whole session about that. Of course, you can read JSON and convert it to SQL data type. So actually, you have two possible ways. So you are using the OpenJSON function, and you can use it with the default schema or the explicit schema, of course. The default schema, of course, when the schema is not specified, and the explicit schema, it's user-defined schema, meaning the returned columns are defined by user itself, of course. So this is the default schema. The result of this approach when casting JSON, when getting JSON in SQL format, you will get a table with 3 columns, the key value and the type, of course, and the type is 0 for null, 1 for string, 2 for int, etc. And when you actually use this approach, it's similar to the XML, because also in XML world you can use this with, and you can specify the return data type. So you can actually specify the columns, what you want to get from the JSON document. Okay, this was short, really short few slides about JSON. So I have demos for all of these, but I will not show them. But I just want to show you one handy example of using JSON, and it's pretty cool. So imagine you have 2 table rows. For example, you have 100 columns, and you want to compare these 2 rows column by column. So actually you want to get only the columns with distinct values. Okay, and this is one example of this. So this is for example, sys databases, you know, the master and the model database. So sys databases is the system table with all the databases in your SQL Server instance. And you have an amazingly 86 columns here. And now your boss come to you and tell you, please give me only the values that are different between the 2 databases. And you are thinking how to solve this, and believe me, but by using JSON, it's pretty cool and easy. So when I run this, you will get only 9 rows here. And actually all the other values are the same except these 9 here. So the column name, database ID, snapshot isolation state, etc. These are only the differences between the master and the model databases. So we started from 86 columns, and only these 9 here are different. So this is really cool way of using JSON. And the other example of using JSON is actually the hash bytes. If you remember, when I was showing you the hash byte, I was using the XML approach. So this is here. Okay, it's not actually important, but yes, I was using for XML auto, and then I was hashing this for comparison. And also I can use for the same thing JSON. And this is actually the hashed value in JSON. And it's really cool if you want to compare 4 rows between 2 tables or systems or whatever. So this is all about JSON now. And I have only this slide. This is cool. So actually, thank you very much to everybody. And I hope that you enjoyed this session. So I have 9 more minutes if somebody has a question or something.
Let's see. Irene says thank you, great session. I agree, really. The picture's also really nice, yeah. And I really like the JSON example. The difference is really cool. For me, JSON was like, well, keep this stuff out of my database, but maybe I should reconsider this approach. Really
yes,
great.
Of course,
yeah.
You must watch the other session because it has some downgrades, because for example, XML, it's much better in SQL world because you can index it. For example, you have two types of indexes for XML data type. It's natively supported in SQL, and JSON should be always casted and converted or something, and you have these performance problems. So you have some techniques actually to make it faster by, for example, computed columns or something.
Yeah.
But of course, sometimes it's really cool, and much more frameworks these days use JSON, and it's really important that actually you have it here.
Yeah.
Thank you, everybody. Thank you, Uwe. I really appreciate for all the great comments I'm seeing in the chat.
Yeah, and it was another question regarding the PowerPoint and the scripts. So if you can send it to Daniel, we will find a way to post them and make them available. Or if you have a website we can share. I shared the GroupBy session you mentioned as a link in the chat as well.
Okay,
so,
let's give me a few seconds, please. And I will paste you in the chat now shared folder, okay?
Great.
Of this session, and with all demos and slides, and just stay on this frequency. Okay.
So while you're looking for the link, we have a last session. I think it's in the other channel. I'm sure it's another channel. It's on SQL Server and snapshots, everything we have been afraid to ask, by Argenis Fernandez. So if you like, please join us there for the last session of the day.
Oh.
And for the rest, thank you for attending. It's really great having you here.
I am sharing it.
Yeah.
Share, get URL, just a second.
Yeah, take your time. I'm here. So a lot of thank you notes in the chat as well. And
thank you very much. Here is no, actually to all attendees. So here is the OneDrive URL. You can find slides here and all the scripts using in this demo.
do you mind if I share the link in the Slack channel for GroupBy as well?
Oh, of course you can.
Yeah. Great. So then I will prepare the post in a few seconds.